Okay, so hi everyone, welcome to Sec 4 Math with me, Teacher Kim, on Thursdays at 8 p.m. I almost say 8:30, 8 p.m. I hope you guys are having a great week. Hope you have attempted the mock paper part 2, okay, on matrices and vectors, because we will be going through that today, okay? Yes. Okay, so general rules before we begin. As usual, please remember to be patient and understanding. Always remember to observe gracious and respectful behavior, and of course, don't be afraid to ask any good and relevant questions. Okay, if you face any technical difficulties during the course of this lesson, don't worry. Our kind moderator, Aisha, is here to help you today. Okay, and for all other lesson-related queries, just feel free to send them in the chat. Okay, I might be talking a little fast because we do have a lot to cover. If you've seen the mock paper, you know why. Okay, so yes, without further ado, let's begin. So what does the mock paper part 2 cover? Matrices as well as vectors. So we'll be doing equal matrices, addition, subtraction, scalar multiplication, as well as everyone's favorite, matrix multiplication. Okay, then for vectors, we will be doing addition and subtraction as well, parallel vectors, and then comparing the area of figures using similar and common height. Okay, yes, let's go. So equal matrices. Hi Denise, if you haven't do the paper, should I do first then watch recorder, or should I just stay? It's up to you. I mean, maybe while I'm doing the recap, you can try to maybe start with the matrices questions, okay? So yeah. If I were you, I would just do the paper first. Yeah, so I'll give myself 30 minutes, okay, 45 minutes, do the full paper, then I come back and watch the recorded. Okay? Yes, okay, very good, Kavya. So let's go. Equal matrices. So two matrices are equal if they have the same order, right? And all their corresponding elements are equal. Yes, very good. Okay, thank you, Denise. Bye. Okay, so that means corresponding means A corresponds to the position W, right? And then B and X, C and Y, and D and Z. Okay, so we have A equals W. So if they are equal, if matrix A equals to matrix B, then yes, thank you. Okay, I know I can go a bit faster. Okay, thanks to all of you telling me the answers. So A equals to W, B equals to X, C equals to Y, and D equals to Z. Okay, so yes, glad to see that all of you are familiar. That's very heartening. Okay, so two matrices can be added or subtracted if and only if they have the same order. Okay, so I hope everyone knows what order of matrix is. Okay, I hope no one is lost. So again, we take the corresponding positions, right, and corresponding elements, and we add them or subtract them together. So for A plus W, we get A plus B, matrix A plus matrix B, we get A plus W, B plus X, C plus Y, and D plus Z. Okay, same for if it was subtract, except that we'll be subtracting instead of adding. Right, so B minus X, C minus Y, D minus Z. Okay? Yes, okay, and note for addition and subtraction, the order of the matrices do not change. Okay, scalar multiplication as well. Okay, so when a matrix A is multiplied by a scalar K, then every element inside that matrix is multiplied by the scalar value K. Okay, so if A equals to matrix A, B, C, D, then K times matrix A equals to KA times KB times KC and KD. Okay, not times, sorry. Okay, and again for scalar multiplication, the order does not change. Okay, very important. Okay, and last one, of course, everyone's favorite thing to do with matrices, matrix multiplication. Right, so we can only multiply two matrices together if the number of columns in the first matrix is equal to the number of rows, okay, in the second matrix. Yes, very good, Kavya. Okay, so what do I mean? So remember, order, we always write it as A something times something, right? So the column must be equal to the row in the second. Okay, and when we multiply these two, so these two must be equal, right? Must be same. Then we can multiply, and then we'll be left with M by P. Okay, so when we multiply two matrices together, the resulting matrix will have order M by P. Okay, and note, matrix A times B is not equal to matrix B times A. Okay, they are rarely ever equal. Okay, clear? Very important. Yes? Okay, good. So how to do matrix multiplication? We look at rows for the first one and we look at columns in the second one. Okay, so we take A, element A times W plus B times Y. Okay, so AW plus BY, that's top row, first column. Now top row, second column will be AX plus BZ. Okay, now bottom row, so now I'm going to look at CD, and then first column first, so it will be CW plus DY, and now second column, so CX plus DZ. Okay, yes, very good. Wow, impressive, good job. Okay, so it seems like everyone is familiar with matrices. So let's start with mock paper question 1. Okay, so a wedding planner is ordering favors for an upcoming wedding. So each bag of wedding favors is to contain 2 tins of honey, 1 scented candle, and 3 red roses. So given that there will be 150 guests at the wedding, find the number of respective items to be purchased and represent your solution in a 1/3 matrix P. Okay, so first we need a row matrix, right? So we have 150 bags, and in each bag we have 3 items, right? We have 2 tins of honey, 1 scented candle, and 3 red roses. So in this case, 1/3. Hi Kavya, why you never mention 1 guest 1 bag? Why if 1 guest take 2 bags? Okay, fine. Noted. For the future mock papers, I will specify. Okay. Yes. Okay. So a row matrix. So I have 3 elements in my row matrix, right? First element 2, second is 1, and then last one is 3. Okay, so this will be scalar. So this question is a scalar multiplication question. Okay, so when you multiply it, you should get matrix 300, 150, and 450. Okay, those of you who gave your answers without brackets, you will not get the marks. Okay, those of you who put comma, okay, also will not get the mark. Can? Okay, next. Part B. Okay, so then the wedding planner is planning to purchase the items from one of the following suppliers. So this table summarizes the price list, okay, quoted for each item. So supplier A supplies 1 tin of honey at $8, 1 scented candle at $6, and 1 red rose at $12 each. Okay, supplier B 10, 5, 10 accordingly. So represent these prices in a 3/2 matrix Q. So this part's pretty simple. Just convert the table into a 3/2 matrix. So you should have 3 rows and 2 columns. Okay, so you should have 8, 6, 12, and 10, 5, 10. Okay, this should be your matrix Q. Okay, if you write this, you get another mark. Okay, now part 2, evaluate T equals to matrix PQ. So P we know is 300, 150, and 450. And then Q is this 3/2 matrix, so 6, 8, 12, 10, 5, 10. Right, so when you multiply these together, do I need to break it down? Okay, maybe I just write the answer and then you guys, if you don't get it, then you just let me know, okay? So we should take 300 times 8 plus 150 times 6 plus 450 times 12. Okay, this should give you 8700. And for the second one, it's 10, 5, and 10. Okay, so 8250, and this should be a row matrix. Okay. Okay. Anyone not sure how I got this matrix? Anyone? Okay, so if no questions, very good job. Then over here, okay, bubble question 1, state what the elements of matrix T represent. Okay, I want you guys to think about it, read through the 4 statements and choose which one you think explains best. Okay, you have 1 minute, your time starts now. Hi Pranav, sure, because the timer is going for this bubble question, I'll go back later. Okay, so sorry. Okay. Oh, you figured it out. Okay, very good. Okay, so what do the elements of matrix T represent? Okay, so the matrix, the elements of, okay, so option 1 says elements of T represent the total cost of purchasing the supplies from each store respectively. Option 2 says elements of T represent the difference between the cost of purchasing the supplies from each store. 3 is the elements of T represent the cost of supplies, and 4 is elements of T represent the most cost-efficient purchase from each store respectively. Okay, so which one do you think? Okay, so the key differences. This one says total cost of purchasing the supplies respectively. This one says difference between the cost of purchasing the supplies. This is cost of supplies, and this is most cost effective or most cost efficient purchase respectively. Okay, so it should be option, let's take a look, very well done. Okay, it should be option 1. And why? Okay, it's definitely not the difference, right? Because we're not subtracting anything at all. In fact, we're just multiplying. Okay, so why not option 3 or 4? So option 3, although correct, okay, is a little bit too vague because represent the cost of supplies. So cost of supplies can be interpreted in many ways. It can be, do you mean the cost of a candle, okay, or the cost of the roses? Okay, it should be the total cost. Okay, and then also option 4, the most cost efficient purchase. So cost efficient purchase means that if it's more affordable, like maybe if we go back to the table, it's more affordable to buy the honey from supplier A and then buy the candle from supplier B. So this would be our most cost efficient, right? If we buy the honey from A and then the candles and the roses from supplier B, that would be what is the most cost efficient. In that way, we would save the most money, right? So that is why it's not option 4 either. Okay? So let's go back to the question. So in part 3, the mock paper asks, state what the elements of T represent. So that is what the bubble question was for. And then hence, determine which supplier the wedding planner should purchase the favors from. Okay, so T is equal to the matrix, 8700 and 8250. Okay, so which supplier should the wedding planner purchase the items from? There should be a part 3, Kavya. It's a B part 3. Okay, so the wedding planner should purchase the supplies from from supplier A or B. So A charges 8,700, B charges 8,250. Okay, so it should be supplier B. Okay. Oh, you just checked? Oh no. Okay, maybe there was a little bit of a translation error between the departments. Okay, so please forgive the teachers, okay, for the technical error. Don't worry, it's just 1 mark. Okay, you can live without it. No, just kidding. Okay, the important thing is that you understand what is happening, okay, in the lesson. Okay, so everyone okay with question 1 in the mock paper? Yes, no? Everyone okay with the question 1? Yes? Anyone has any questions? Okay, no questions, then we move on. Okay, next part, magnitude of a vector. Okay, so immediately we're moving on to vectors already. Yes, next is everyone's favorite chapter, vectors, right? See, everyone loves vectors. All the seniors, every year, all the students I teach, they love vectors so much. Okay, so magnitude of a vector. So how do we find the magnitude of a vector? Essentially, it's just Pythagoras theorem, right? Okay, so we find the number of units moved along the x-axis and the number of units moved along the y-axis. Okay, horizontal and vertical. Okay, so any column, any vector, sorry, I almost said matrix, any vector can be represented as a column vector x, y, okay, where x represents the number of units moved horizontally, y represents the number of units moved vertically. Yes, and then to find the magnitude or the length, right, we just use Pythagoras theorem, so x squared plus y squared square root. Can? I hope you guys remember this. Next, vector addition. Okay, so we have triangle law as well as parallelogram law. Like I said, okay, in previous lessons, this is both ways work. Okay, it's like, you know, if you want to drive from Pasir Ris to Jurong, there are many ways you can go. You can go through Orchard Road, or you can go all the way to Sentosa, then you go back up. Okay, or you can go all the way to Yishun and then you go to Jurong. There are so many ways you can drive there, right? But they all bring you to the same destination. Just that some are nearer, some a bit further, maybe some the journey is a bit smoother, right? Okay, so triangle law, if we have vector AB plus AC, then okay, for triangle law, we need to make sure that these 2 points are the same. Wherever we pause, right, wherever we take a pause for a toilet break, we need to start or continue our journey from that point. Okay, so this will give us vector AC. And we can also represent vectors as a small letter P or bolded. Okay, Q, bolded is usually for the question, like I always say. Okay, if we want to write it out, then we write it with a curly worm on the bottom, right? So P plus Q gives us resultant vector R, right? And we write R with the curly bracket, not bracket, curly worm, squiggly worm, yes. Okay, yes, thank you. Javier can read my mind already. I think I always say the same things. That's why. Okay, good. At least it's getting into your heads. Okay, then parallelogram law. Okay, for parallelogram law, if we have AB plus AD, since we draw, then we do a parallelogram, right? So if it's a parallelogram, then we say that AD is equal to BC. Okay, so this will be Q. So AB plus BC will give us again AC. Correct? Then or vector P plus vector Q equals to resultant vector R. Okay? Yes, so this is a recap. Very good. Okay, good job. Then we have subtraction as well. Okay, so xy minus zy. Okay, in this case, these two need to be the same. Okay, so we get zx. Okay, oh sorry, no, this is addition of negative vector, so that's not how we do it. To do addition of negative vector, we do xy. Okay, so we flip. Okay, so this will be plus negative zy, which is xy plus the negative of zy will be yz. Okay, then we realize, oh, we have y and y, so we can cancel, right? And we end up with resultant vector xz. Okay, this is addition of negative vector. Again, like I say, whichever way you prefer, right? Okay, you can use addition of negative vectors or you can use triangle law, whichever you feel is more comfortable for you. Okay, you want to drive, you want to go sightsee, you want to drive all the way to Malaysia, then back to Jurong, also can. Okay. You want to go from Pasir Ris, then you go to Woodlands, then you go Malaysia, then you come back to Jurong, also can. Okay. Then we have, okay, we can also write it as vector A minus vector B, which will give us vector C, okay, in the diagram. Then Zx minus Zy, okay, if we're using triangle law, then we need to make sure that the starting letters are the same, okay, and we will end up with resultant vector Yx. Okay, so always the back one first. Okay, and vector A minus vector B gives us, again, vector C. Okay, so you can also use parallelogram. Like I said, there are many ways, okay, to get to the same thing. Yeah, that's the beauty of math, right? Like you can do 1 plus 1 equals 2, or you can do 1 plus 1 plus 0 minus plus 2 minus 2 equals still 1. So I mean, it still equals to 2. So yeah, so there are many ways you can get there. Some longer, some shorter, some faster, some slower. Okay, I know I've said this multiple times. So yes, all about what you prefer, what method suits you best. Okay, and yeah, what method prevents you from making careless mistakes. Okay, so it's all about learning about yourself also. So position vectors, next part of our recap. So in general, very important concept, position vectors. Okay, if a point A has coordinates xy, then we say that the position vector OA is written as column vector xy. Okay, then using the triangle law of subtraction to solve for vector AB, we can say that vector AB is equal to vector OB minus OA. Okay, so this is your reverse triangle law. Can? So that brings us to mock paper question 2A. Okay, so the coordinates of A and B are this and that respectively. So find the column vector AB. So part 1 is pretty simple. I hope. Okay, maybe I just test you guys. Does anyone know? Does everyone know the position vectors of A and B? What are the position vectors of A? What is the position vector of B? Anyone? Okay, so from triangle law, very good, Sean. Well done. Okay, what about B? Very good. Wow, well done. Okay, so from triangle law, we know that we can write vector AB equal to vector OB minus OA, right? So from here, I'm just going to fill in the column vectors. So position vector of B will be -1, 4. OA will be 2, 3. Okay, then from here, it's just subtracting, right? Like our matrices. So -1, okay, -2, and 4 minus 3. So that's going to give us -3, 1. Okay, so if you got this, again, another mark. Okay? Yes, very good, Kavya. Well done. Okay, now part 2, so part 2, find magnitude of vector AB. So magnitude is just our Pythagoras theorem, right? So we square root -3 squared plus 1 squared. Okay, which should give you square root 10, which is equal to, not a nice number, 3.1625 2, 2, 7. Okay, 1, 2, 3, 4, 5 decimal places. So I round it off. Since it's not specified, just round off to 3 SF. Okay, so we get 3.16 units. Okay, 3S.F. Okay, so Kavya asked a very good question. Can I leave it in cert form? For E-Math, no. Okay, for A-Math, yes. Yeah, so I know those of you who take A-Math, you should be very, very familiar with your certs, okay, with your indices in general, okay, manipulating certs. But for E-Math, answers are always left to 3SF, okay? We don't leave our answers in certs, okay? It would be considered as incomplete if you leave your answer as a cert. Okay, now part 3. Given that BA equals to 2AC, find the coordinates of point C. Okay, so let's start with finding AC first. So column vector AC is equal to OC minus OA, right? From our triangle law. So we don't know what the coordinates of C are, so I'll just let it be XY. And then OA I know is 2, 3. So from here, I can find my column vector AC, which will be x minus 2, y minus 3. Okay, then I have my given equation, BA equals to 2 vector AC. So BA is the reverse of vector AB. So that's how I get 3, 1, 3, negative 1 equals to 2 of AC, which is x minus 2, y minus 3. Then from here, I start with my scalar multiplication first. Okay, so 3, negative 1 equals to 2x minus 4, 2y minus 6. Then I have equal vectors. So how to do equal vectors? Okay, to do equal vectors, we get 3 equals to 2x minus 4. And negative 1 equals to 2y minus 6. Okay, can you guys see? Okay, still can. Then 2x equals to 7, x equals to 3.5. Okay, 2y equals to 5, and y equals to 2.5. Can see? Okay, so what are the coordinates of, right? They want the coordinates of point C. So let me continue up here. Okay, so for your answer, you should have C bracket 3.5, comma 2.5. Okay, if you stop here, if your workings end here, again, you do not get the full marks. Okay, you will get method marks, but you won't get the one answer mark. Okay, so you'll be short of 1 mark. Can? So you need to present your answer clearly. Okay, because the question asks for coordinates. Got it? Any questions? Anyone? Okay, no questions then? Thank you, Kavya. Okay, no questions then. Part B. Okay, so that was part A. Now part B. So the point S has coordinates negative 3, 9, and column vector ST is equal to negative 2, 4. Hi Pranav, are there multiplication for vectors? There is multiplication, but it's not like matrix multiplication. It's scalar multiplication. Okay, which you will see later on in the paper as well. Okay, yeah. So point S has coordinates this, and S column vector ST is that. Okay, so find the equation of the line ST. Okay, so anyone knows how to find the gradient? Okay, so whenever we want to find the equation of a line, we need two things, right? We need the gradient, and then we need the y-intercept. So how to find the gradient? Anyone? y1 minus y2 over x1 minus x2. Yes, but do we have 2 points? For that formula, we need to have the 2 pairs of coordinates, right? How to find t? Okay, so this one, there is a shortcut. So if you visualize, this is our line, ST. So I have point S and T over here, and my line cuts through these 2 points, right? And they say that from S to T, I move 2 units to the left and 4 units up. So in this way, is this... Yes, oh my goodness. Yes, shortcut. Okay, so that's the purpose of this question. Okay, so that you guys know, then next time when you see this kind of questions, you don't do the long method again. Okay, it's all about learning. Okay, so to find the gradient, you can actually just use your column vector for negative 2, 4, where you put the y value on top. Okay, so 4 over negative 2, and you will get the gradient negative 2. Can? Then to find equation, now we need to find, so we have the equation ST should be y equals to negative 2x plus c, right? Then to find our value of c, we sub in a pair of coordinates. So sub x equal to negative 3, y equals to 9. Okay, so 9 equals to negative 2 times negative 3 plus c. You should get c equals to 3. So y equals to negative 2x plus 3. Okay? Hi Kavya, but if we find coordinates of t, then we can sub that in. Yes, of course you can. Okay, you will still arrive at the same answer. Like I said, okay, you can, it's just that method is longer lah, but yeah, it's like driving again. Okay, you can drive, take a shorter route, longer route, as long as you get to the end point, it's fine. Okay? Okay, so is part 1 okay for everyone? Okay, then now we have part 2. So the equation of another line, MN, is blah, blah, blah. Okay, so find the coordinates of the intersection. Okay, so intersection, okay, to find intersection, what does that mean? What topic is this on? Anyone? Whenever we talk about intersection of 2 lines, that would be, very good Kavya, simultaneous linear equations, right? Okay, so we have equation 1, y equals negative 2x plus 3, and equation 2 given to us, 2y equals to 2x plus 9, right? Then we solve for x and y. Okay, you can do substitution or elimination. Again, either one, whichever you feel comfortable with. I'm just going to do substitution. Okay, so sub equation 1 into equation 2. So 2 negative 2x plus 3 equals to 2x plus 9. Negative 4x plus 6 equals to 2x plus 9. And 6x equals to negative 3. X equals to negative half. Okay. Maybe I save some space, write as decimal. Sub x equals to negative half into equation 1. So I get y equals negative 2 times negative half plus 3. It's going to give me 1 plus 3. So y equals to 4. So the coordinates of my intersection will be negative half, comma, 4. Okay? Hi Kavya, in exam, are the numbers going to be this nice? Not guaranteed, okay? I worked backwards to make sure that we get nice numbers, but yeah, not always. You might not always get nice numbers. Okay, it might be an ugly fraction like 2 over 3, so that students put their, so that some students will round off, and then they leave their answer at 0.666, and then they don't get the answer, because you should leave your answer as exact whenever possible, right? It states on the cover page. So if the answer is 2 over 3 and you leave your answer at 0.666, then you don't get the marks. Okay, so it might not always be nice numbers, but yeah. Is part 2 okay? Yes, no? Okay. Then bubble question 2. Okay, so this one is the next mock paper question. Question 3. So in the diagram, we have ABCD, which is a parallelogram. So it's given to you that it is a parallelogram, so you don't have to assume. Okay, and diagonals AC and BD intersect at point G. Okay, then point E lies on BD such that BE to ED is 2:3. F lies on BC such that BF to FC is 2:1. Okay, so find the value of K where BC equals to K of BF. Okay, so what is that value of K? You guys have 1 minute for this. Okay, your time starts now. Okay, think about it. What is the value of K? So we are looking at BC and BF. Okay, so this ratio here. So F lies on BC such that BF to FC is 2:1. Okay, so BF Okay, so BF is 2 units. And then FC is 1 unit. Okay, so what is the value of K where BC, this whole thing, BC so BC equals to how many of BF? Okay. Okay, so let's take a look at the results. Fingers crossed. Okay, very good job. Okay, yes. Okay, so we know that BF is 2 units. So BC will be how many units altogether? Anyone? So BF is 2 units. BC will be how many units? 3 units, right? Okay, so if we want BC over BF, this will be 3/2. So BC equals to 3/2 of BF. Okay, does everyone see how we get the value of K? So K is equal to 3/2, which is also equal to 1.5. Okay, so that is how we arrive at option 1. Okay? Yes, Kavya, 90% accuracy. Very good job, okay, class? Very, very good job. Okay, so okay, yes, you can also put in the arrows, but I'm just doing it for as a magnitude, okay? Because since we're talking about units, so it's fine in this case. Okay? Now, okay, so back to the actual question. So 3A, so part 1, express in terms of P and or Q, vector BC. Okay, so how to find vector BC? So we know that BC is equal to 3/2 of BF, right? Where BF is equal to vector P. Okay, so BC equals to 3/2 P. Can? Part 2. Find vector CA. So CA is over here. Okay, then we have CG. CG is equal to Q, but it tells us that CA. Oh, so to find CA, how do we do that? CA. Suddenly don't know. Oh, right. Okay, so since this is a parallelogram and this is the diagonal, what do we know? BC BC plus CA. We are finding CA, Kavya. So how would you find CA? GC equals to AG. Yes. Okay, yes. So because this is a parallelogram and it's stated that BD and AC are diagonals, right? They intersect at point G. So we know that, okay, CG is equal to GA. Okay, so we know that CA is equal to 2 times of CG, which will be equal to 2Q. Can? Very good. Okay, then part 3, BA. Yeah, so now we have to do a little bit of computation. So BA, to find vector BA, we need to start from B. Then where do we go? How would you guys do it? So BA, very good, Kavya. We would, okay, personally, I would do the same thing. I would start from B, go to C, then from C, go to A, right? Because this utilizes our answers from the first 2 parts. Okay, of course, there are other ways to do it as well. Okay, you are free to explore all the other options. Okay, so BA, okay, but personally, I'll do BA equals to BC plus CA. Okay, so BC I know is 3 over 2P and CA is 2Q. Okay, now part 4, BE. Okay, so now to find BE. So BE, so point E lies on BD such that BE to ED is 2 is to 3. So first things first, what do we need to find? First things first, we need to find, yes, we need to find BD. Very good. Okay, so first we need to find BD. And how do we find BD? How to find BD? Very good. Okay, we would take BD equals to BC plus CD. Okay, then since, okay, but we don't have CD, right? We don't have CD, but what do we have? What other vector is equal to CD? Very good, Kavya. It's equal to BA, right? Since this is a parallelogram. Okay, so very important, since ABCD is a parallelogram, okay, CD equal to BA. Okay, that's why we can just swap them out like that. Okay, then we fill in the values. So BC is 3 over 2P plus BA, which is 3 over 2P plus 2Q. Okay, so 1.5 plus 1.5, that gives us 3P plus 2Q. Can? Must we write the reasoning in the exam? Although they don't say that you must write it, I would recommend that you write it, okay? Because, yeah, it just solidifies your explanation, and if it ever came up, right, they would not have any reason to deduct any marks from you. Okay, it's just to protect your own marks. Yeah, so I would recommend that you write it, okay? Even though some schools say that you don't have to. Can? Okay, then last part, part 5. Okay, please let me know if I'm going too fast. Okay, if anyone has any questions, please feel free to send them in. Okay, part 5, vector AE. Okay, so to find AE, we can do... Oh, wait, no, I'm not done with part 4. Sorry, I want to find BE. So BE is equal to how much of BD? So this is 2 units, this is 3 units, so this is 2 out of 5 of BD. Okay, so 2 out of 5 of 3P plus 2Q. Then I need to solve, so that's 6 over 5p plus 4 over 5q. Okay, I know I said it before in previous lessons, but please make sure, okay, when you draw your squiggly line, don't let it go under the numerical values as well. Okay, the squiggly line is only for the vector. Okay, is that clear? Okay, so now that we found BE, then we can do part 5. Let me think about where I have space. Okay, so I will write above my head. If at any point you guys cannot see, let me know. Okay, so I'll draw this line. Okay, and part 5, let's go. Okay, so part 5, AE. Okay, so to find AE, I will do AB plus BE. Very good, Kavya. Very, very good. Okay, seems like someone's been practicing. Okay, so AB plus BE. Then I fill in those values. So AB is, okay, let me put my equal sign here. So AB is the reverse of this, right? So negative 3 over 2p minus 2q plus BE, which is 6 over 5p plus 4 over 5q. Okay, then we simplify, calculate this. Okay, and you should get negative 3 over 10p minus 6 over 5q. Can? Is this okay? Oh my goodness. Very good, Kavya. Okay, yes. Okay, so everyone. Okay, so now from here, okay, B part 1. So use the vectors to show that points A, E, and F are collinear. So this is where just now earlier Pranav asked, right, do we have multiplication? So you see that we do actually use multiplication in vectors, right, where we multiply. So one vector is a multiple of another, and then we can use it, right, not just to expand but to also factorize and simplify. Okay, but it's not like matrix multiplication. Okay, so then how do we also prove collinearity? Yes, this word still cannot. Okay, how do we prove that these 3 points are collinear? Yes, let me rephrase that sentence. Okay, to do that, again, we need to use multiplication, right? We need to show that one vector is a multiple of another, okay, and that they contain a common point. Yes, very good, Kavya. So key statement that the marker will look for, okay, is AE equals to KEF or something like that, okay, or AF equals to KEF, something like that, as long as there is a common point, okay, either a repeat of letter A, letter E, or letter F, either one, okay. Yes, so let's do that. Okay, so from the previous part, let me write down. Okay, so first we need to find vector AF. Okay, so AF would be AB plus BF. Okay, plus BF, which from the previous part A, we already found vector AB, right? So AB is negative 3 over 2p minus 2q plus BF, which is just vector P. Okay? And we simplify this to get negative half P minus 2q. Okay? Then, let's find vector AE. What would vector AE be? So AE we did in part 5 over here. So AE equals to negative 3 over 10p minus 6 over 5q. Okay, so let's look at, so we have p and q in both. Okay, then is there any way we can factorize one or the other to make them multiples of each other? Which vector would I start with? Anyone can tell me? Would I start with vector AF or AE? Okay, usually I take the uglier one, okay, which in this case would be AE. Okay, so I factorize, okay, so maybe I factorize out 1 out of 10 first. Okay, actually I can just factorize out 3 out of 10 immediately. No, 3 out of, if I factorize out 3 out of 10, okay, let's see, then I get negative P minus 6 out of 5 divide by 3 out of 10. That's going to give me 4q. Okay, then I see, oh, I need half and 2. So I'm going to divide this, so it's 3 over 5. Then I multiply in the half, so I get negative half p minus 2q. Okay, so you can actually just factorize out 3 over 5. Yes, thank you, Kavya. Okay, yes, so we can factorize out 3 over 5. So we skip this double step. Yeah, cannot shift. Okay, so equal 3 over 5. So I factorize out 3 over 5. Then I have negative half p minus 2q, which I know is equal to vector AF, right? So there I have AE equals to 3 over 5 of AF. So remember my statement, how do I conclude? So since AE equals to KAF, where K equals to 3 over 5 is a constant and K not equal to 0. Okay, if you want to be clearer, okay, where K equals 3 over 5 is a constant, K not equal to 0, and A is a common point, right? Since A is present in both vectors. Okay, yes, so since... Hiyo, practice writing it out. I hope you did write it out, okay, in the mock paper. K and A is a common point. Then, okay, or therefore, points A, comma, E and F are collinear. Okay, so always remember... Okay, very good, Kavya, as long as you did it at least once. Okay, so always remember this very important statement. Okay, so always state that one vector is a multiple of the other, where K is what value, state that it is a constant, state that it is not equal 0, and if you are proving collinear, then state the common point as well. Okay, can? Ooh, sorry. Yes, okay. So in the diagram, A, B, C, D, oh my goodness, time flies so fast. Okay, so in the diagram, A, B, C, D is a parallelogram, blah, blah, blah. Okay, use vectors to show that F, E, and C, G are not parallel. So how do we find vector F, E? So first things first, we need to find vector F, E. So F, E equals to, would do F, B, plus BE. Okay, since we have, okay, so FB will be negative P, since it's just the reverse, right? If this direction is P, then backwards would be negative 5p. And BE, we know from the previous parts, okay, from part A, is equal to 6 over 5p plus 4 over 5q. Okay, then simplify, so you get 1 over 5p plus 4 over 5q. Then how to prove that they are not parallel? So CG, we know, is equal to vector q. So is there any way we can express this vector as a multiple of that? So since FE, very good, yeah, because there is this vector p, right? So there's no way we can just factorize out a numerical number and somehow they will equal. Okay, there's no way we can multiply by a numerical value. So since FE is not equal to K of CG, okay, where K is a constant that is not equal to 0, FE and CG are not parallel. Okay? Yes, unless K equals to 0, right? That's the only possible way. Okay, vector P cannot equal to 0 because then this line wouldn't exist at all. Okay? So, part C, okay, so this part, okay, is a little bit more complex. I hope, did anyone manage to try this part C in the paper? Yay! Okay, how do you find it? How was it? Out of us, on a scale of 1 to 10. Oh, okay, that's not too bad. Okay. Okay, so there are two ways we can think about area. Okay, so either similarity and congruency, right, from Sec 2, Sec 3, or we can use common height, which is like your primary school formula. Okay, yeah, so it is quite confusing if you don't understand it. That's quite true, Pranav. Okay, but it, like I said, like a lot of things, it takes practice. So it takes a bit of getting used to. Like you need to visualize the shapes and then look for that common height or figure out whether are they similar shapes or are they not similar. And then if they are not similar, then you need to use the common height. And then you need to visualize that common height. Okay, so let's break it down. Let's do it together. So express the following as a fraction in its simplest form. So over here we have area of ABE, which is this shape, over area of ABD, which is the whole triangle. So first things first, let's look at these two shapes. Are they similar? So ABE and ABD. Are they similar shapes? Would you consider these two? Not in 100 years, yes. Okay. Yeah, so they are not similar. So since they are not similar, okay, definitely we would have to use common height. Right, so where would the common height be? It would always lie, okay, so I always like to take the base, okay, which is this common line between BE and BD, right? So that would be my base. Okay, let me draw this triangle first. Okay, then I would draw a dotted line that is perpendicular to my base. Okay, I know that does not look perpendicular, but okay, you get the idea. Okay, so this would be my height. Okay, so when I calculate the area of ABE over area of ABD, okay, I use my primary school formula, half times base times height. So for ABE, my base would be BE, right? So I have half times base BE times height. Okay, then for triangle ABD, I have half times base and my height is still the same. same line, right? It's half times BD times height. Okay, so then I realize I can cancel out the half, I can cancel out the height, so I get BE over BD, which is my fraction 2 over 5. Okay, so very well done. Very good job, Kavya. Okay, so everyone okay with this part 1? Yes, good job. Okay, so questions like these are usually 2 to 3 marks each. Okay, so next one, part 2, area of AED. So this time it's the other side, AED over ABCD. So again, are these two shapes similar? So these two shapes are obviously not similar because one is a triangle and one is a parallelogram. But what do we know? Okay, we realize that AED and ABE form half of this parallelogram, right? Yeah, so we know from part A that this yellow portion is 2 units. This yellow portion is 2 units and the whole thing is 5 units. So can anyone tell me how many units would this green portion be? Very good. Yes, it would be 3 units, right? So we know that triangle, so from part A, we know that triangle AED over ABD would be 5 minus 2 over 5, which is 3 over 5. Correct? Then to do AED over ABCD, ABCD would be 2 times of ABD, right? So it would be 3 over 2 times 5. Okay, so that will give us, very good Kavya, 3 over 10. Okay? Yes. Anyone has any questions? Anyone not sure? Still not sure? Want to clarify? Okay, so if no questions, then very good job. Okay, that is it for mock paper part 2. Next week we will be going through part 3, so do try it out, okay, before the lesson next Thursday. Okay, yes, and yeah, that's it for today. Please take care. Those of you who have any questions, want to screenshot anything, feel free to let me know now. Okay, I'll stay here for another 5 minutes. Otherwise, the rest of you, I look forward to seeing you guys again next week. Take care, stay safe. Bye.